Hello and welcome to our channel. Today we have an incredibly exciting development from the world of science and space to share with you. For the first time ever, scientists have pinpointed the source of a methane plume on Mars. This discovery could have profound implications for our understanding of the red planet and even the potential for life beyond Earth. So why is this such a big deal? Well, methane is a gas that on Earth is largely produced by biological processes. The presence of methane on Mars has long been a subject of intrigue and speculation among scientists. It raises tantalizing questions. Could there be life on Mars, even if it's microbial? Or could there be some unknown geological processes at work that we don't yet fully understand? The breakthrough came thanks to a collaboration between the European Space Agency's Mars Express orbiter and NASA's Curiosity rover. The Mars Express detected a plume of methane in the atmosphere above Gale Crater, where Curiosity is exploring. Curiosity, equipped with its own sophisticated instruments, confirmed the presence of methane in the same location. This correlation between the orbiter and rover data allowed scientists to trace the methane back to its source. Gale Crater is an ancient and intriguing landscape. It's believed to have once hosted liquid water, making it a prime location for searching for signs of past life. The detection of methane here adds another layer of mystery and excitement. Scientists are now focusing on understanding whether the methane is being released by biological activity or through chemical reactions involving water and rock. Methane on Mars is intriguing because it can be produced by both biological and non-biological processes. On Earth, most methane is produced by living organisms, such as microbes that digest organic material and release methane as a waste product. However, methane can also be produced through abiotic processes, such as the interaction between water and certain types of rock. This means that the presence of methane alone isn't a definitive sign of life, but it's a strong indicator that something interesting is happening. The Curiosity rover has been exploring Gale Crater since it landed on Mars in 2012. It has been studying the geology and climate of Mars to help scientists understand whether the planet could have supported microbial life in its ancient past. The discovery of methane in Gale Crater is particularly exciting because it suggests that there might be active processes currently happening on Mars. This adds to the evidence that Mars is not a dead planet, but rather one that might still be geologically and possibly biologically active. The detection of methane on Mars has a long history. It was first detected in the Martian atmosphere by ground-based telescopes in the early 2000s. Since then, various missions have observed fluctuating levels of methane, which has puzzled scientists. Methane is quickly broken down by ultraviolet radiation from the sun, so its presence suggests that it must be replenished by some source. The new discovery by Mars Express and Curiosity helps narrow down the potential sources and provides a clearer picture of where the methane might be coming from. One of the leading theories for the source of the methane is serpentinization, a geological process where certain types of rocks interact with water to produce methane. This process does not require the presence of life and could be happening deep beneath the Martian surface. However, the possibility that microbial life is producing the methane cannot be ruled out. On Earth, microbes known as methanogens thrive in environments where they produce methane from carbon dioxide and hydrogen, such as in deep-sea hydrothermal vents. If similar conditions exist on Mars, it's possible that methanogens could be present and contributing to the methane levels. The discovery of methane on Mars also has implications for future missions. NASA's upcoming Mars Sample Return mission aims to collect samples of Martian rock and soil and bring them back to Earth for detailed analysis. These samples could help scientists determine the exact composition and origin of the methane, providing more clues about the potential for life on Mars. Additionally, the European Space Agency's ExoMars rover, scheduled to launch in the near future, will carry instruments specifically designed to search for signs of life and study the composition of Martian gases, including methane. This discovery is not just about Mars. It has broader implications for our search for life in the universe. If we can understand the processes that produce methane on Mars, we can better interpret the presence of this gas on other planets and moons. For instance, Saturn's moon Enceladus and Jupiter's moon Europa both have subsurface oceans and have shown signs of geological activity that could produce methane. Imagine the possibilities if we find similar methane plumes on these icy worlds. It could be a sign that we are not alone in the universe. The search for life beyond Earth is one of the most compelling endeavors in science, and discoveries like this one bring us closer to answering that age-old question. The presence of methane on Mars, combined with the evidence of ancient water, creates a compelling case for the red planet as a target in our quest to find life elsewhere. But there's still much work to be done. Scientists need to determine the exact mechanisms behind the methane production and release on Mars. Future missions, both robotic and potentially human, will play a crucial role in unraveling these mysteries. The study of methane on Mars is just one piece of a larger puzzle that includes understanding the planet's climate history, its potential for past habitability, and its capacity to support life today. Every discovery brings us a step closer to answering one of humanity's most profound questions. Are we alone in the universe? Moreover, this discovery has broader implications for the field of astrobiology and the search for extraterrestrial life. Methane is considered a potential biosignature gas, meaning its detection on other planets or moons could indicate the presence of life. By studying the sources and behaviors of methane on Mars, scientists can refine their methods and tools for detecting life elsewhere in the solar system and beyond. The implications of this discovery extend to the future of space exploration. As we continue to explore Mars and other celestial bodies, understanding the presence and sources of methane will be crucial in guiding where we look for signs of life. This knowledge will also be instrumental in the design of future missions, ensuring that we have the right instruments and strategies to detect and analyze potential biosignatures. For instance, the upcoming Mars Sample Return mission, a collaborative effort between NASA and the European Space Agency, aims to bring Martian samples back to Earth for detailed analysis. By examining these samples in state-of-the-art laboratories, scientists hope to uncover more clues about the origins and significance of Martian methane. Such missions could provide definitive answers about the potential for life on Mars and help us understand the planet's geological and climatic history. Furthermore, this discovery emphasizes the importance of international collaboration in space exploration. The combined efforts of the European Space Agency's Mars Express orbiter and NASA's Curiosity rover demonstrate how teamwork and shared expertise can lead to groundbreaking discoveries. As we continue to explore the cosmos, collaboration between nations and space agencies will be essential in overcoming challenges and achieving our scientific goals. The discovery of methane on Mars also sparks excitement and curiosity among the general public. It captures the imagination and inspires a sense of wonder about the possibilities of life beyond Earth. Public interest and support are crucial for the continued funding and success of space missions. By engaging the public in these discoveries and sharing the excitement of exploration, we can inspire the next generation of scientists, engineers, and space enthusiasts. So, what do you think about this groundbreaking discovery? Could we be on the verge of finding life beyond Earth? Or are there other explanations for the methane on Mars? Let us know your thoughts in the comments below. And don't forget to like, subscribe, and hit the bell icon for more exciting updates from the world of science and space. Stay curious, and until next time, keep looking up.